প্রবলেমস অন সিম্পল স্ট্রেস। আজকে আমরা সিম্পল স্ট্রেসের উপর একটি ম্যাথের সলিউশন করব। যে শুরুতেই ম্যাথটি পড়ে নেওয়া যাক, কি লেখা আছে, কি মান দেওয়া আছে। দ্য লিঙ্ক শোন mode of AISI C1045 is still as rolled is subjected to a tensile load of 8,000 pound. Let ACE is equal 1.5 B. If the load is repeated but not reversed, determine the dimension of the section with the design based on number A, ultimate strength, number B, yield strength, number C. If the link, which is 15 inch long, must not elongate more than 0.005 inch, what should be the dimension of the cross section? তো শুরুতেই ভ্যালুগুলো লিখে নেওয়া যাক যেগুলো দেওয়া আছে। আমরা যদি ফিগারের সাহায্যে দেখাই তাহলে এমন হবে। টেনসাইল স্ট্রেস এখানে দেওয়া আছে 8,000 pound or 8 kips, which is tensile stress. So here 8,000 pound or 8 kips, and here ACE is equal 1.5, এখানে 1.5 এটা B, এটা H, and length is 15 inch length. 15 inch length. AISIC 1045 is still as rolled. So we found the value of ultimate stress and yield stress from table at 7 from books. So here we see C1045 as rolled. SU, the value of ultimate stress is 96 and SY is 59 KSI. So we write the value. SU is equal 96 KSI and SY is equal to 59 KSI. 59 KSI. And here is given that the load is repeated, but not reversed. So we get the value of design factor for ultimate strength and yield strength from table 1.1 from books. We write here we see the load is a repeated load and one direction. That means the load is not reversed. So the value of NU is 6 and NY is 3. Now we write the value on the page. Now we have to find out the dimension of ACE and B for ultimate strength and yield strength. So first we find out for ultimate strength. For ultimate strength, we know design stress. That means SD is equal SU by NU. So we know the value of SU is 96 and NU is 6. 96 by 6, that means 116 ksi. And again we know SD is equal to design stress is equal to F by A. So here F is given 8 kips, and A for the steel, and cross-sectional area is equal B and B multiplication A's 8 by B. Here that given that A's is equal to 1.5 B, so we write B into 1.5 into B, and SD we know that we given from 16, so B square is equal 8 by 16 into 1.5. Okay, B is equal 8 by 16 into 1.5 root over. So we got the value of B is equal 0.575, and we can write it standard fractions, and standard fractions, so we can help from the book. For 0.575 we can 575, the value is lies between that 3 by 16 to 7 by 8. So if we calculated it, then we got 9 by 16 inch. By the same procedure we can find the value dimension of B and A is for yield strength. I just see the calculation. We know SD is equal to SY by NY for yield strength, and given that we found out the SY for yield strength is 59 and NY is 3, and again we know SD is equal to F by A, that means SD is equal to 59 by 3, and F is 8, and A is 1.5 B square. 1.5 B square. So we got the value of B is equal to 0.52. That we can write it for standard fraction. We can write it 18 by 16 approximately, which is we can write again half inch, and so is AS is equal to 1.5 into 1.5 into B, that means 0.52. so we can write standard fraction 3 by 4 inch. I forgot the value for ultimate strength, the AS, so we can, for ultimate strength, AS is equal 1.5 into 0.575. so we got the value is 7 by 8 inch. Okay, now we find the value for number question. We know for rod steel the modulus of elasticity E is equal 30 into 10 to the power 6 psi, and we know modulus of elasticity is equal FL by AL. Here L is the elongation. We can write del. So we have all the value. Thirteen to 10 to the power 6. F is 8,000. Here the value is psi, pound per inch square, and here is the value F is pound, so we can write it pound unit. And L is 15 inch, and A we know 1.5 b square, and elongation is given 0.005. So we got B is equal 0.73, and for standard fraction we can write 3/4 inch. So A is equal to 1.5 b, and the value is 9/8. Standard fraction we can write again 1/8 inch. So here's our answer. For better view, I will see you the note paper, and you can able to write from here. If you have any problem, tell me on comment section. I will try to answer your question. Thank you so much.